Dear students, Assalamu alaikum. Today we are starting our new chapter Dobby shading. In this chapter, we will try to understand what Dobby shading systems are, how they are different from cam shading system, what are different features of Dobby systems, how they can help us to have more number of frames and more versatile design of the woven fabrics. So let's get started. Dear students, let's talk about different type of shading systems. Basically, shading systems are the reason of moving the frames on the machine or it causes the split of the warp into shed, and from this shed we then pass our weft. So there are many possibilities of forming this shed with various mechanisms. I have highlighted here three main and one today's shading system. You can see in the gray over here, like here the cam shading, then Dobby shading, Jacquard shading, and today's shading, electronic shading. If you talk about any of these, any of shading, any of the shading system can be a positive shading system or a negative shading system. Positive being operating the both movements of the frame upward and downward positively in a controlled manner, and negative mean only one direction movement, that is raising of the frames is controlled by the shading system, and the return is caused by the some restoring media, that can be spring, that can be some elastic medium or a gravity. So if the both motion are controlled by the shading system, it is called positive shading system, otherwise negative. Or in the case of cam shading, negative cam shading is the single cams, they control only one way motion. That is, generally we name them tapered shading. But if the cams are double cam, conjugate cam, one complements the other's movement. They are called positive cam shadings. The cams are less sophisticated system, more simple system, can be used for very basic weaves, not uh, maximum number of frames that are different from one another within a weave can be 8. If we require more number of frames, we can go for Dobby shading. Again, Dobby shading can be positive and negative, but there is another possibility that we call rotary Dobby shading. And all the Dobbies, they can be a single lift Dobby or a double lift Dobby. Then we have other mechanisms for the various type of Dobbies that we will discuss. Jacquard shading, we already know, is the shading that causes the split of the shed because of each individual yarn's raising or lowering. More sophisticated but more complex system. And today's shading system is controlling the frames or Jacquard motion, frame shading or Jacquard motion, both of these, with the help of individual control of the elements by using motors. They do not use any type of mechanical system in a sense, and each individual element is controlled by the rotation of the positive rotation or negative rotation of the motor that causes the lifting of the frame or the Jacquard elements, that is harness. So let's talk about more. Dear students, if we talk about cam shading system, I want to mention here that cam shading system follows the principle of rotating the cams. By installing these cams on a shaft, that is generally a bottom shaft or a cam shaft. For example, over here you can see an example of shuttle weaving machines side view line diagram. You can see handle frames over here, and these handle frames are attached with some leverage system, and they are following two tappets, negative cams, tappets, and these tappets are installed on this central shaft that is called bottom shaft. Like you can see over here, this bottom shaft, if we see the drive of the machine, we can see that the drives come from the main motor to the crankshaft, the top shaft of the machine. That is the shaft from where we measure the RPM of the machine. Then this drives to this bottom shaft, on which we install these tappets. On today's machine, what happened is these frames are being connected with different lever systems, and these lever systems are connected to the jacks, and these jacks are following the cams on the camshaft. This is the camshaft, and this camshaft is getting drive from this driving shaft, and this driving shaft is connected to the motor of the machine. Here you can see the picture on top view. This is the drive shaft, this is the camshaft, and this camshaft is being installed with different various type of cams over here, and these are the followers which drive these jacks and ultimately lever system and the frames. Here is another view of the same cam motion, and this cam motion can be illustrated over here that these positive cams are installed on this central shaft, camshaft, and these jacks are operating our lever system, this one, for the frames. So in this slide I want to mention that for two cams we have to reduce the drive, the motion, the rotation of our bottom shaft, camshaft, one half, that is one half of the crankshaft. And if we increase the cams, we will have to reduce its motion further. More the number of cams, more the rotation we have to reduce. For reduction of today's machines, for example strawberry cam box, we use pair system of gears. These gears are installed over here, this drive shaft and camshaft over here. You can see the various type of pairs, and these pair helps us to reduce the motion of the camshaft as required. For the higher number of cams to be used, reduced motion will be here. In this slide I want to mention, students, about limitation of cam shading system. For this I want to let you show how cam works. Cam basically is an eccentric disc. This eccentric disc has a very special kind of profile, outer surface. This outer surface profile is followed by a roller and a lever system, and this roller and lever system helps us translate our rotatory movement in a special kind of uh, to and fro motion, and its time period and motion type can be controlled by the profile of the cam. Uh, for for uh, for the shutting system, we name it a tappet when we only control one type of movement of a frame with the help of cam, and this tappet is shown over here. I want to show you that you have to focus on the how the restriction of the this white shaft cross section will be limited. One example is I am showing over here. You can see in the first example when we have two tappets, and the two tappets will uh, be joined on the cam and at difference of 180 degree. That is on the rightmost side you can see the yellow area for movement of one cam. The topmost cam you can see the notch at the top, and here you can see that the machine, the camshaft is its rotation is half to the total rotation for one cam. And if we increase the number of cams, for example, from 2 to 4, then you can see this yellow area has reduced to 1/4 of the total rotation of the camshaft or the bottom shaft. On the rightmost side you can see the for the one cam the rotation is 1/4 of the total rotation. And if we still increase the number of cam from 4 to 8, you can see over here the area has further reduced to 1/8 of the total rotation. For 1/8, we need to control three type of movements of frame, that is raising on the frame and letting it stop at the topmost position, that is called dwell time. And then we have to lower the frame downwards, and these three motions, if we equally divide that, so it will be the 1/8 of a circular rotation would be 45 degree. And if we divide these three motions in further, that we will have 15 degree for raising the frame, 15 degrees for uh, dwell time, and 15 degrees for loading the frame. So in this way we are reducing too much time, and the time and the force will not be available if we further reduce, that is we use more than 8 frame on the cam shutting system. That limits the cams to maximum to the 8 cams for one weave. So over here I have just mentioned that increasing the cam limits the movement, limits the time available for the camshaft to impart the motion to the frame, and reducing it further than the 45 degree will not help to effectively raise or lower the frame or give it a dwell time. That is why 8 number of frames is the limit for our cam shading system. Dear students, on this slide I want to summarize what we discussed just in previous slides. So cams are installed on our bottom shaft on the weaving machine. So we saw that yes, our cams are installed on a shaft that generally in shuttle weaving case it would be the bottom shaft, but today's weaving machine where we can use the cam box, the shaft would be cam shaft. So shaft cams are installed on cam shafts or bottom shaft. As we increase the number of frames, we have to reduce the rotation of camshaft as compared to the other movement. For example, crankshaft. Crankshaft rotates. Crankshaft is the it is rotating for one complete cycle, one complete rotation for one reference session. So it gives us the RPM of the machine. So in comparison to that, our bottom shaft or our cam shaft will keep on reducing its motion when we increase the number of cams or number of frames on the machine. If we have two frames, the camshaft would have one half of the rotation. If we have four frames, it would have one fourth of the rotation of the crankshaft. And then if we have eight frames, so it will have one eighth of the movement of the crankshaft. For example, if crankshaft is working at 800 rpm, the bottom shaft or camshaft should work for 100 rpm for the 8 frames. When we decrease this movement of the camshaft, uh, the only that cam will be operating the frame. Let's suppose we have 7 we will have as 8 and certain. So 8 and certain, we will be moving one frame, and for one pick for we will have 1/8 portion available from the bottom shaft. So we buy the time of movement of frame when we reduce the movement of the camshaft. This 1/8 portion is causing to move only one frame, and then this 1/8 portion move further and further till the whole rotation of the camshaft rotates, and all the frame would have inserted one weft. For example, in the case of 8 and certain. So what happened is this reduction in the camshaft motion bias the time for individual frame to be moved or lower. Control three movement of the frame, that is raising, lowering, and keeping it at the topmost position, that is 12 time. And these three motions would be control only the that time slots that we will allot out of the camshaft to the one frame. And that is why when we are using 8 frame, we will be only available 45 degree, that is 15 degree for each three motions. That is very small time available, and it will also limit the force that we can exert on the frame. That is why we do not reduce further from these 8 frames. The efficiency of the controlling the shedding motion will not be enough. That is why we have limitation of 8 frames on cam shedding system. Generally, we have straight draft and basic waves like 12s. So that is why we will have the when we have 8 frames, we can insert maximum 8 picks repeat. Um, so repeats of wefts are similar to the warp repeat generally. So weft repeat is also mentioned over here. When we require exceeding requirement of more than 8 frames or 8 picks, then we will have to use Dobby shading system. That is where Dobby shading comes in, and justification of using the Dobby shading is when we require more than 8 frames. There is a possibility that we are using 10 frames, even though we are not breaking this rule of 8 frames. That is when we have striped satin fabric. You see as stripes making, one stripe is making satin weave, one other is satin weave, and each require 5 frames. So combination of 5 and 5 is 10 frames. Still it is not, because this 8 frame requirement is for one weave, because we are using two weaves. That is why this does not break. Similarly, in the case of salvage may have other weave, and the body may have the other weave. Still there will be a combination, and it will not break this rule of 8 frames for one weave. So with this slide, I have completed what I want to convey to you, that how the cam shedding system limits have the limit, and how the justification for Dobby shedding system is possible. So whenever you require to decide between shedding, cam shedding or Dobby shedding, you can go to you can now decide for if you will go for the cam shedding or Dobby shedding. Thank you. We will continue on the next slide. Dear students, after we saw the cam shading limitation and cam shading reduction, and how it compared with the uh, Dobby shading system. Now let's see what Dobby shading system is. Dobby shading system basically is more sophisticated system than our cam shading system. We do not limit only to one shaft or only one type of movement. We can have a multiple type of movements. For example, we can have we can control selectively our frames, which frame to lift and which frame not to lift, and that makes us free from this one shaft there causing the movement, and this movement is translating into the frame. It is now not like that. We can select from various frames available. We can select which frame to lift and which not to lift, and this independence just gives us independence from the what is happening to the other frame. So we can lift very isolatedly from the other frame, either the adjacent frame is lower or up. It does not connect with each other. So this independence from other frames helps us give a sophistication of the Dobby system, that we can lift a frame whenever we require, and we lower the frame whenever we require. Does not bind because of this having on the same shaft. So this is more sophisticated than the cam shading system, and that it also makes possible for us to have very large number of frames, maybe 30 up to 30 frames it is possible. And this independence from the other frame also helps us to use as many number of wefts as we require. Does not find the limitation of a profile is available only for 8 picks, like in cam shading. It does not happen over here. So virtually we are free to have any number of weft repeats possible. I just want to give you an overview in a quick last slide of today's. So I will just tell you that there are basically three systems available for Dobby. We can divide three subsystems of a Dobby system, any Dobby system. So our first system is the hook selection system. The hook selection system would be uh, we have some type of lever system. There can be many type of selection of hook selection system. For example, we have paper Dobby. We have papers to be translate our design to the machine. We have wooden letters or metallic letters on which we use pegs, and this peg translate the design to the machine. We can have electronic control that we feed the design from the machine panel, and it translate to the lifting of selection of the frames. So there can be a hook selection can be done in various ways. For example, over here we are looking at the we can have a feeler system. These are the very sensitive levers, and these levers feel the presence of a peg of a pin or a peg present on the wooden lattice. This is the design drum that introduce each next lattice of wood with the pegs or not pegs, and this translate the selection of the hooks. If the hooks are raised, it does not engage with our uh, motion transmission system. So we have the hook selection system, then we have the motion transmission. You can see over there the K1 and K2 are the knives, and this arrow is indicating the motion that is being received from the machine is translated to these two knives. These knives alternatively moves, and if these hooks are engaged to the knife, the motion is transmitted upon the input from the hook selection system. If hook selection system does the input to the hooks, and the hooks are engaged to the knife, the motion is transmitted. Otherwise, the frame does not get the transmission of motion and stays at the bottom position. If it gets the motion, it is pushed forward and the frame is lifted. Then the third system is the system that actually translate this the hooks push or pull uh, into the frames lifting or lowering. So we have a jack over here and the cords that attach to the frame stop, and then we have the spring at the bottom. This is the most conventional system on the shuttle machines or maybe some older machines. The new machines are this is more positive. This is not this is type of example. You are looking at the negative example. The springs are involved, but today we can have a positive system, double jack that can lift and lower at the both motion controlled by this system. So so these are the three subsystem of any Dobby shutting system that works together. We will see that there are various variation. For example, single lift we have only one hook. Double lift we have two hooks. We can have T lever for the motion transmission. For the old Dobbies, the better Dobbies use cams, and maybe the newest Dobbies does not use this hooks and knife system, but it use a rotary transmission of motion system. And in the new machine we do not see pegs or paper, but we use electronically control the selection of the hooks. And over here the mechan we use lever system, solid rods and levers, and connection levers, so that we there is no lag for then machine can work at higher rpm. So in further lectures we will be looking at the Dobby different type of Dobby shuttle system. I just was here to give you an overview how the Dobby systems are. So that's conclude our today's lecture, and we will resume in other lectures with the different Dobby shading systems. Thank you very much.